Welcome students. In these two videos we will be taking a look at finding the perimeter of a triangle and also finding the area of a triangle. And what's important about these is the fact that they're not setting like they're not having a flat edge down, setting it down where we can find the base and the altitude very easily. So we've got to do something different to find the area and do something a little bit different to find the perimeter. So on this problem, we're going to find the perimeter, and on this one, we're going to find the area. But on your worksheet, you're supposed to do both on every problem. I'm just going to kind of split and conquer here and show you the ideas behind the two. On both type of problems, the first thing that you have to do is find the, you have to draw a rectangle around the triangle on both type of problems. So we're going to draw a rectangle around that. We're going to circumscribe the triangle inside this rectangle. Now what that does for us, it gives us three triangles. Do you see them right here? We're going to call that one triangle 1, T1. Over here we'll call this one T2, and then T3. And the idea is that if I can find the dimensions for the legs of this one, find the dimensions, I think I have them right there, I'll have to check them here in just a second, find the dimensions of these, it'll help us find the hypotenuse. So there's the hypotenuse to this right triangle, here's the hypotenuse to this right triangle, and then there's the hypotenuse to this right triangle. Okay, so let's go ahead and then let's find this. So I've got 4 plus 5 plus 5, that's 14, plus another 4 will give me 18, and I have a total of, it looks like it's 1, 2, 3, 4, 5. So the dimensions of T1 is 18 and 5. Now if I look at T2 right here, it looks like I have 5, 10, 11, and then I have 4, 9, and 13, 14. So T2 is, I think it's 15. So yeah, there's 10 there, plus 1, plus 4. So T2 is 11 times 15. And then T3 over here on the left-hand side, I've got 3, and then there's 5, 10, 15, and another one. A unit of 1 will give me 16 up. Now what we need to do is use the leg squared plus leg squared to find the hypotenuse. So we'll take T1. I've got 18 squared plus 5 squared, which is going to give me a number. For T2, I have 11 squared plus 15 squared. I'm going to get me a number there and take the square root of it. And then T3 over here, we'll do 3 squared plus 16 squared. Okay, we get out our calculator and we'll find all these things. So 18 squared, looks like I have it right there already. So that gives me 349, and the square root of 349 is 18.68. So 18.68, and that was the square root of 349 is what we did. Now let's find it for T2, triangle number 2. So I have 11 squared plus 15 squared, and that gives me 346, so 346. I want to take the square root of 346 to find the hypotenuse. And let's see what we have here. Take the square root by taking it to the 0.5 power. And I get 18.6. So this is almost an isosceles triangle, right? These two sides are almost equal. Now I have to find the last one. And then we're almost done with this problem. So we'll take 3 squared plus 16 squared. And that gives me 256, and the square root of 256 is 12.3. We'll go 12.27. Square root of 256, wasn't it? 265. Okay, so now we find the perimeter. We'll add all these together. So I'll take 18.68 plus 18.6 plus, what was that one? 16.27. 16.27. Now it doesn't look right there. Let me change that number. So 16.27. So we add all these sides up, it gives us our perimeter. So here we go. I've got 18.6968 plus 18.6. Got a hard time with my calculator here. 18.6, and then the last one I have is that 16.27. So there's the perimeter, 53.55. So the perimeter for this one is 53.55. So if I was dealing in feet, that would be in feet, right? Because it's only a linear unit. I'm not dealing with an area. Now on this next one over here, we're going to do the area. And here I have the steps. So the first step is to draw a rectangle around the triangle, find the dimensions of T1, T2, T3, and we have to, sometimes you're going to have this R1 here, and I'll talk about that in a minute. And then we have this large rectangle. This large rectangle is what we're going to be drawing here in just a second. So basically the idea is I'm going to take this large rectangle, find its area, and all these smaller rectangles, T1, T2, and on sometimes you're going to have a little piece. We may have a little piece right here that we're going to have to cut out of the big rectangle, and I'll explain that in just a second. So let's go ahead and draw this. There we go, and I'll show you what we're talking about. Okay, we're going to make these triangles. You see there's one triangle right there. There's T1. There's T2, and then there's T3. Now we want the area, and remember the area is 1/2 base times height. So the idea is I find the area of this big one, I subtract that one out, subtract the area of this one out, subtract the area of this one out, subtract this one out, and what I end up getting is the area of just the inside of triangle ABC. So let's find the dimensions of this. So we'll call this in T1. Remember to find the area. It's 1/2 the base times the height. So the height is 1, 2, 3, 4, 5. So that's 5 times 1, 2, 3, 4, 5, 6, 7, 8. 5 times 8. Now that half will take that to a 4. So that area of T1 right here, that's going to be 20. Now we'll do this big one. That side looks like it's 9. We've got 5, 10, 15. So that side is 19. So the area of this triangle will be 1/2 times the base. We'll use 9, and the height is 19. I can't do that one in my head. And then down here for this one over here, which is, we'll call that one T2. And then I have T3. And I have a 1/2. The height here is 1. We'll call the length, that's 4. Looks like it's 14. 5, 5, and 4. That's times 14. So that one's easy to find. That's going to be 7. And then this little rectangle right here, do you see how this isn't accounted for? I have to subtract this out to get the area right here. So that one right there looks like it's just going to be 5 for R1. A little rectangle is just going to be 5. 1, 2, 3, 4, 5. Okay, now we're ready to go. So we found the area of all of our triangles in our little rectangle. Now we have to find the area of the big one. And that looks like that's going to be 9 times 19, right? So area of the large rectangle will be 9 times 19. Okay, I'm going to go ahead and find the dimensions of all these. Clear this out. So I have 20, I got 9 times 19. That's going to be 171. And then the area of this triangle here that I have to subtract out, that's the same idea there, right? But I'm going to divide it by 2. It's 85.5. Now I'm going to do what it says here. Take 171, subtract 20 from it, subtract 85.5 from it, subtract 7 from it, subtract 5 from it, and that's going to be my area of this triangle. So we'll go clear on that. So I have 171 minus 20 minus 85.5 minus 7 and then minus 5. That gives me 53.5. So that area on this one is 53.5. Now, if you wanted to find the perimeter of this one, you use the same dimensions here to find the hypotenuse, 3 sides, and you could add them together. And on this one over here, if you wanted to find the area, you basically do the same thing. Now, what will happen over here, you see you won't have any other little rectangle like this, will you? Because we don't have that on this, and so you just have to deal with the 3 rectangles or the 3 triangles and subtracting from the big rectangle. So that's how you find the area of geometric figures in a coordinate plane. Sometimes if you have a diagonal, you want to find the perimeter, use the Pythagorean theorem. If you're finding an area, you just kind of do whatever you have to do. Sometimes you'll have to draw a rectangle, whatever it may be, and then subtract the areas from the larger area, like on a composite figure. Okay, thanks for watching this video, and you guys have a great afternoon. Bye-bye.